Hi everyone, welcome back. We're going to work on 1.4 today, and we're going to be focusing on minima, maxima, and even and odd functions. So I already have the essential question written right there. So how do I find the minimum and maximum of a quadratic function? And what makes a function even or odd? So we're going to be able to determine all of these today based on a variety of functions with a focus on quadratic functions or parabolas for the minimum and maximum. Now, in the textbook that you guys use in class, there is a section called relative minimum and maximum values. And this talks about the fact that there are points on a function that might be the lowest compared to the points around it, or the highest compared to the points around it. So looking at this function, for example, we see that this one is called a relative maxima, because it's the highest one relative to the points around it. So it's not the highest one of the entire function, but it's one of the higher points. Same for these two. This one right here is not the lowest, but it's still a relative minimum because it's among the lowest points when compared with the points directly around it. Okay? So although we do want to cover this, we won't be covering it at this point because a lot of minimum and maximum type questions involving these special functions require you to have a graphing calculator, and we're not going to be focusing on that just yet. Instead, we're going to be working with parabolas, and you guys should have experience with parabolas in Algebra 1 so that we can use the vertex instead to find our minimum and maximum values. Okay, so let's go ahead and start. So again, there's the essential question if you still need it. But I'm going to go ahead and start with a few reminders. So first off, when we're talking about a parabola, we're usually dealing with a quadratic function. So quadratic functions are those that look like ax squared plus bx plus c. So again, that's a quadratic function. And these usually result in parabolas, or pretty much always actually. So when you have these functions, you know that you're going to end up with something that looks like this, or perhaps like this. And it all depends on how your quadratic function is set up. A lot of you might remember that if you have a negative a in the front, that your parabola is going to be going downwards. Now, this is going to be the basis of our minimum and maximum. So here, with a parabola going downwards, this point, known as the vertex, or the topmost point, is going to be our maximum. And I'm not referring it to as a maxima, because this is actually the highest point of this particular function. It is still a maxima, but it's also a maximum. Over here, this is the lowest point of this parabola, or this function. So this would be our vertex, and it's also a minimum. So because we want to focus on the ability to solve for these algebraically, we're going to go ahead and try to recall how to find the vertex of parabolas. If you know or remember, the vertex is written as a coordinate point, xy. The x value is calculated using a very special formula. For those of you shouting it out, it is indeed negative b over 2a. So, negative b over 2a is for the x value and the x value only. So I'm going to draw an arrow and remind us it's only for the x value. Okay? To get the y coordinate of your vertex, you would substitute your x value, the one that you find right here, into the function. And then you solve for f of x. Okay? So, we're going to go ahead and do one example with a quadratic function. So, example A, we have f of x equals negative 4x squared plus 8x minus 10. Now recall we do label these. A is negative 4, B is 8, and C is negative 10. So remember that I just mentioned that because I have a negative A, our parabola, is going to be going downwards. Now this is not an accurate sketch. I'm just showing us that what we're going to be looking for is a maximum. Okay? So let's go ahead and find out what this maximum is. Using my negative b over 2a, I'm going to plug in. I get 8 over 2 times negative 4. And that allows me, oh, I forgot. Don't forget that negative. So negative b over 2a. So negative 8 over negative 8. That's going to be positive 1. So our x value for the vertex is going to be positive 1. So maybe I want to write that over here just to remind myself, don't lose it, 1. The y value I'm going to get after I plug in this x value that I just found into the function. So I'm going to take f of 1, substitute the 1 in for all of my x values, and I go ahead and simplify. So 1 squared is 1. 1 times negative 4, negative 4. 1 times 8 is 8. And then we have negative 10. So simplifying straight across, negative 4 plus 8 is 4. 4 minus 10, negative 6. So f of 1 is negative 6, which means my vertex is 1, 6. And I know my parabola is pointing downwards, so my minimum, or the maximum, sorry, maximum for this function is the point 1, 6. Okay? So, our maximum occurs at the point 1, 6. Some questions might ask what your maximum value is, and in that case it's usually the y value. So for this one it would be 6, but I'd like to express it as a point, so the maximum for this function is a point 1, 6. Alright, so that's it for that example. Let's go ahead and move on to even and odd functions now. This one's going to require a little bit more space than I have, so I'm going to go ahead and turn the page. Separate my columns again. And what I want you guys to copy down really quickly, let me turn down to this page, is some information about even and odd functions. Now we're going to show it algebraically, however I'm also going to explain what it is graphically. So go ahead and copy down this box right here, the test for even and odd functions. You'll be able to solve for it algebraically by using negative x. I'll show you guys 3 different examples for this just to make sure we understand all the different types. Okay, so copy it down, pause if you need to. I'm going to go ahead and start right now by first showing that, oh, here we go, that for an odd function is symmetric with itself in respect to the origin. Now, respect to the origin is kind of confusing, but it's basically across this diagonal line. So if you were to rotate this image by 180 degrees, it would be exactly the same. So it's an odd function. An even function, on the other hand, let me twist this one, is one that's symmetric with respect to the y-axis. In other words, I could fold it over this line right in the middle, and it would be symmetric to itself, and it would fold right over. Okay? So that would be an even function. And then, of course, those that are neither have no symmetry whatsoever. They're not symmetric to the origin, nor are they to the y-axis. So they're neither even nor odd. Okay? So those are some visual examples. If you want to go ahead and rewind it and replay so that you can sketch them real quick, it'd be a good idea too. However, we're going to focus on the algebraic solutions. Okay? So, over here, let me zoom out for you. We're going to go ahead and do 3 examples to show the even, odd, and neither. So let's go ahead to example B, and let's call it B1. I have 3x squared minus 2x. Alright, what I want to do, and actually let's call this f of x. What I want to do is substitute a negative x in and see what happens to this function with a negative x. So this becomes 3 times negative x squared minus 2 times negative x. Negative x inside the parentheses squared stays in x, so I get 3x squared. Over here I have a negative 2 times a negative x, which means I end up with a positive 2x. Now compare this to the original function. The 3x squared has stayed the same, but the negative 2x and the positive 2x are obviously different. So because it wasn't a complete change or completely the same, this is neither. Alright, so it's neither even nor odd. That might seem a little confusing, but let's go ahead and see another example with B2, where we have 10x to the 4th minus 8x squared plus 55 equals f of x. Okay. So with this one, I'm going to once again substitute in a negative x. This negative x helps me determine whether or not my functions are even or odd. So I once again plug in my negative x into all of my x values. And in this one, negative x to the 4th power, it stays a positive x. Here, negative x squared again stays positive, so I have a negative 8x squared. And plus 55 doesn't change at all. So once again, compare these two. Actually, a good way to write it is that we keep the f of negative x right there. So we compare f of x with f of negative x. Our two functions are exactly alike, so this is even. Alright, so because f of x is all of this and f of negative x is the same exact thing, it's even. And let's go ahead and do one more example. I'm pretty sure you can guess what type it will be, but let's go ahead and show it anyway. So 4x cubed minus 5x equals f of x. And then I'm going to do f of negative x. Sorry for my notation, I should be writing this first. 4 negative x cubed minus 5 times negative x. Negative x cubed stays negative x, okay? Because it's negative 1 cubed stays negative 1. X cubed is x cubed. So negative 1 times 4 will be negative 4 x cubed. Negative 5 times negative x is a positive 5x. So f of negative x is equal to negative 4x cubed plus 5x, while f of x was equal to 4x cubed minus 5x. Notice that they are completely opposite of each other. We have a positive 4x cubed and a negative 4x cubed. We have a negative 5x and a positive 5x. Because they are completely opposite of each other, this function is odd. Alright? So, again, really the only trick is to plug in that negative x, substitute it in for all of our x values, and compare this result to the original function. And with that, you'll be able to determine whether your function is even, odd, or neither. Alright, so that's the end of the notes for today. Go ahead, rewind, review if you need to. Otherwise, go ahead and click the Google Forms and answer the questions. Have a good day, guys.